RH criteria, special cases in RH criteria. When we are preparing RH table, in RH table, okay, so if the first element is 0 anywhere, first element itself is 0, further calculations will give trouble, In that case, we have to assume a small positive value epsilon. That first element must be, okay, a small positive. Assume first element as a small positive epsilon, and then complete the array. Complete the array means RH table. Complete the array means RH table. Once we finish the complete table, replace that epsilon is 0. Replace that epsilon back to 0. Wherever epsilon is there, back to 0. Okay. Just we will try a problem in this model. Find the stability of the control system having characteristic equation. Okay. This given equation is characteristic equation. We have to prepare RH table from the characteristic equation. We have to prepare RH table from the characteristic equation. Okay. So we are in simple, we are writing CE. Now coming to RH table, it is S power 4, S cube, S square, S power 1, S power 0. Okay, this is our table. And if we write the elements, first term, third term, fifth term, it is 1, 1, 1. We will go to the second row. Second term, fourth term. The coefficients are 2, 2. Okay, first two rows completed. Now we have to go with further calculation. So it is 2 into 1 minus 1 into 2 divided by 2. You know how I am doing it. Okay, 2 into 1 minus 1 into 2. Okay, divided by 2 I am doing. So this is 0 by 2. The value is 0. Okay. Now the next element, how to calculate? 2 into 1 minus 1 into 0 divided by 2. It is 2 by 2. Value is 1. Okay. So S power 2 row completed. But if you see, when we can go with the next row calculation, it is 0 into 2. Okay, 0 into 2 minus 2 into 1 divided by 0 we have to do. Okay, divided by 0 means that gives infinity value. Always it will be a problem. So what we will do in the first column, okay, any row having first element 0. Now, you need not worry about the first column. So any row first element is 0 means we will assume that element as epsilon, a small constant. Okay, let epsilon tends to 0. Okay, a small constant. Epsilon is a small constant. Okay, let means assume. We are making assumption. Okay, now if we go with further calculation, it is epsilon into 2, because that is epsilon hereafter, it is not 0. Hereafter it is epsilon. Epsilon into 2 minus 2 into 1 divided by epsilon. Okay, so we cannot simplify this because epsilon is a variable. I will write as it is 2 epsilon minus 2 by epsilon. Okay, next element I cannot calculate because in the previous two rows there are no elements. Now I will go with the last row. Calculation. I have to calculate like this. Okay, minus, this is epsilon. It is not 0, it is epsilon. But here it is 0. Okay, so how I have to calculate? 2 epsilon minus 2 divided by epsilon into 1 minus epsilon into 0. We are assuming this 0 as epsilon. Okay, epsilon into 0 divided by 2 epsilon minus 2 by epsilon. So second term not there. In the first term, this whole thing will get cancelled. Okay, we will be left out only with the value 1. Okay, we are assuming this 0 as epsilon. We have come to the end of the table. Okay, Now, after reaching the end of the table, you replace wherever epsilon is there back to 0. So our table now, it will be, when you replace it back to 0, it is 1, 1, 1, 2, 2, then it is 0, 1, Then if you put the next element wherever epsilon is 0, it is 0 minus 2 by 0. Okay, 0 minus 2 by 0. Here the element is, okay, just I will write the calculation. Okay, it is 0 minus 2 by 0, which means, okay, minus 2 by 0, which means minus infinity. Here I will write minus infinity is the value. Minus infinity is the value. Okay, now the last element, it is 1. That is a constant, no epsilon present. As it is, we will write. This is the final RH table. This is the final RH table. When we call it a final, we are substituting epsilon back to 0. Epsilon back to 0, then we are calling it, okay, final RH table. So this is our table. Now you go with the analysis. First column, any sign changes present. Then based on that, we can tell system is stable or not. Here it is positive 1, positive 2, no sign change. 0 is also positive only, no sign change. Here one sign change is there. Okay, positive 2, minus infinity, one sign change. Minus infinity to back positive again. Okay, number of sign changes equal to 2. Number of sign changes equal to 2. Okay, which means number of roots on RHS. Number of roots on RHS equal to 2. So based on this, our conclusion is system unstable. Based on this, our conclusion is system unstable. Okay, so what we have done in step 1, we proceeded with general. Okay, in step 1, we proceeded with general calculation, RH table, preparing RH table, and then general calculation. And on the way, we assumed in the first element, anywhere it is 0, we assumed it as epsilon, completed the RH table. Then we have gone with step 2, replacing epsilon back to 0 calculation. The final RH table will come. And this is our step 3. This is our step 3. Okay, our final conclusion is system unstable. Okay, system unstable. This infinity we are calculating like this. This infinity we are calculating like this. Okay, this is about the special case, one of the special case in RH table, one of the special case in RH table. Now I will go with